Good evening, everyone. In today's class, we're going to cover or we're going to start differentiation using first principle. Now, in that formula, differentiation of any function, derivative of any function, let it be f of x here. So, differentiation of f of x equals limit h tending to 0, f of x plus h minus f of x divided by h. Now, how does differentiation is equal to this? Differentiation of any function is nothing but the slope. So, there are multiple ways to find the slope of a given curve or a straight line. One of the best way of finding slope is using the derivative. So, differentiation. Now, I'm just going to explain you in simple form, how does this formula is formed. How does this f of x plus h minus f of x by h comes in. Now, let's consider two neighboring points in a function, in a curve. So, one point is x comma f of x and the other point is x plus h comma f of x plus h. So, we all know that f of x means y. So, any point will be x comma y. So, instead of giving x comma y, I took it as x comma f of x. So, this is one point in a curve. Now, the point which is pretty close to this, which means the h value is slightly above than what you have in x. So, imagine if x is 2, um, x plus h would be 2.1. So, what is h here? 0.1. Okay, so x plus h is a point which is close to f of x comma f of x. So two neighboring point x comma f of x, x plus h comma f of x plus h. So one will be x1 y1, another one will be x2 y2. So we find slope generally using y2 minus y1 by x2 minus x1 formula. So if two coordinates of a line segment or a curve is given, x2 y2 is here, x1 y1 is here, applied in the formula, you get this. Y2 is this, y1 is this, x2 is this, and x1 is this. So you get this. So x get cancelled. In the end, m equals to f of x plus h minus f of x by h. So that is how slope expression, and you apply limit h tends to 0 on that, if that answer is equal to the derivative of the function. And it will be always h tending to 0. We don't need to change this. Now, let's prove differentiation of x power n, which is nx power n minus 1 using the first principle. Differentiation of x power n is nx power n minus 1. This we are going to you're going to prove this by first principle. So here the function is x power n. So we are about to differentiate x power n. So this is the formula which I just showed you the top. The same formula I've written it one more time. Now, derivative of f of x meaning derivative of x power n. F of x is x power n, so f of x plus h will be x plus h to the power of n. And f of x is x to the power of n by h as it is. Now, when you see this one is in the standard limit form of limit extending to a x power n minus a power n by x minus c. But then we need to work a little bit on this in order to change it to exactly that form. So I'm going to add plus x and minus x to the denominator, which I did here. And after that, I'm grouping the term in the denominator. So I group it like this. Now it is x plus h to the power of n minus x power n by x plus h minus x. Now while doing limits, when you apply a standard limit, we must be sure that it is exactly to this point. We changed the function to this form, but the limit is not being changed. Here a, if it's whatever a here, x should tend to a. Whereas here in the place of a we have x, but h is tending to 0. So I need to change my limit. When h is tending to 0, adding x on both sides, x plus h will all tends to x. So I am assuming that x plus h is equal to z. So z tends to x. So wherever there is x plus h, I am going to change it to z form. So this is how it comes to. Now it is perfectly in the standard form. So answer would be n a bar n minus 1. A here is x, so it will be nx bar n minus 1. So this is differentiation of x bar n using the first principle. So here I have taken x power n differentiation, an example of differentiation of x power n using the first principle. Function is x power n. Derivative formula dx of f of x is f of x plus h, limit x tends to 0, f of x plus h minus f of x by h. So in the place of f of x, we have to apply x to the power x cube. So f of x plus h becomes x plus h the whole cube. F of x is x cube by h. Adding plus x and minus x to the denominator, just like the previous explanation, previous model, we group the term so that we can fit this into the standard limit. So everything is same, change the limit also. It comes to the form of z tends to x, z to the power of 3 minus x to the power of 3 by z minus x. So here n is 3 and a is x. So whenever it is in this form, the answer is n a power n minus 1. Here it is 3x power 3 minus 1 because n is 3 and a is x here. So we get 3x squared. So derivative of x cube is 3x. So there is three more sums based on this type. I would like to explain them quickly to you all. F of x is ax plus b. We need to use first principle to differentiate this. So here there is formula limit h tends to 0, f of x plus h minus f of x by h. Since f of x is ax plus b, f of x plus h would be substituting x as x plus h. So this is one of a crucial point that you need to keep in mind. If f of x is ax plus b, f of x plus h would be f of x plus h would be simply substituting that in the place of x. So it will come like this. So with that, we get this as our f of x plus h minus f of x. F of x is the question itself. So that is applied here. Now a into x, a into h. So you get this. Now most terms will get cancelled. We get ah by h. The answer is a. So therefore, differentiation of ax plus b, if you directly do it also, you get a into 1 plus b, so plus 0. So therefore, answer is a. Here also we got a as the answer by using first principle. Next, differentiation of x. F of x is x here. So using the formula, we get f of x plus h is x plus h minus x plus x minus x get cancelled. We have h by h. H by h is 1. Therefore, there is no place to apply h limit, but still the answer is 1. So when you directly differentiate x, what do you get? You get 1 only, no? So we get the same answer by using the limit method. And then the root x. Now, if the function is root x, my f of x plus h will become root over x plus h minus f of x becomes root x. So this is similar to x power n. So I am adding plus x minus x to the denominator. It is in the form of x to the power x plus h to the power of half minus x power half divided by x plus h minus x. Now h tending to 0, x plus h will tend to x. So z form. So therefore, applying the standard limit, we get this as the answer. So this is some simple models based on exponent differentiation using first principle. Based on that, you can try all these sums comfortably. Hope my class